Hello, this is Gary Marr, and in this screen capture I want to talk about one of my favorite tools for building Python scripts called PyScripter. PyScripter is an integrated development environment, which in short means that it's a software program that allows me to look at my code, edit my code, change my code, test my code. It also has things like syntax coloring and other little tools built into it that help my productivity as a programmer. IDEs exist for all programming languages. Some IDEs are very generic, like Visual Studio Code, perhaps Notepad. Some are very specific, like in this case, PyScripter. PyScripter is available on SourceForge, but it is only a Windows program. It's not written for Apple or Linux. But there are other products that work in those environments just fine also. This is a little bit more rigorous than what we have with Thony, which is a great Python IDE for learning Python. But one of the weaknesses that Thony has is in the area of debugging code. So what I'm going to show you with this particular product is how the debugger works. Now, debugging is a very important tool to have as part of your IDE, because typically syntax errors, the interpreter is going to flag. You're going to fix your spelling errors, your typos, whatever, and off you go. But occasionally what will happen is either the code will not execute in the sequence that you plan on having it execute, or perhaps you have a perfectly executing program that gives you the wrong answer. Now, typically these problems are caused by logic errors. In other words, there's a failure or flaw in your design, or runtime errors, which means that you should have been more careful on the validation of data, and for some reason maybe you're trying to turn a letter into a number, which it's not going to like to do. It may fail only part of the times with runtime errors, and the rest of the time may work fine. But in all cases, if you're trying to trace through your code to see the sequence of how the statements are being executed, or to see how the values have changed, the debugger is invaluable. So what I've got here is on the left-hand side of the screen, I've got a File Explorer. Over here, the major window is the code window. And then down here, it says Python Interpreter, but there's actually several things that I can select to look at. And one of the nice things in terms of when you're debugging your program is to watch the local and global variables change as the program is executing. Now, this particular example is probably a little advanced still. This is about what the programmers call arrays, but what Python calls lists, tuples, sets, and dictionaries. For some reason, even though Python follows many of the same standards as other programming languages, when it comes to arrays, it calls it something a little bit different. So just bear with me on this. You can think of this as being just 4 values stored in memory next to each other, identified by a common name, and actually accessed by an index number, which would be starting at 0, 1, 2, 3. Think of it kind of like addresses on a house. This will all be something we'll cover later in the class, but for now that's probably enough to know, because really the basis for this screen capture is to talk about the debugger. Since I have a loop here, and I have to make sure the loop is working correctly, I might want to keep an eye on that part of my code. What I'm going to do is I'm going to click on this line here. Whoops, I missed it. That line. The print not found value. It's on line, looks like 15. Once I've clicked on that outside line number, I get a little red circle with a green check mark in it. This is called a breakpoint. Now, with debuggers, you have breakpoints, which allow the code to stop so that you can execute and then walk through your code line by line. There's also the concept of watch points, which what they call watches down here, where you can identify certain variables that you want to display on the side of your IDE, showing how their values change as the program is executing. We're not going to worry about that one. What I want to show you is a breakpoint and how that's going to help you find errors in your code. So I've got my breakpoint identified, and if I want to take it off, I just simply unclick it. Okay, I'm going to click it on. And up here in the command line, or the ribbon, I should say, command ribbon, a lot of this stuff, excuse me, is the same as every other Windows GUI product you've seen. New file, File Explorer, etc., print, and search. What I'm looking for here is the Run button, and then specifically to the right of it, something called the Debug button. So when I click on this button, what will happen is the program will execute until it finds the breakpoint, and then it stops execution. Since that was the line identified as the breakpoint, it stopped at that point. Okay, now from here, what I can do is I can hold my cursor over the top of various variables that came before the breakpoint line and inspect the contents, okay? So what I have here is a value of 99 in script. I have a search value of 99. So basically what this is saying is I'll look until you find my search value inside the array of 99. Looks like it's the last one in the actual array. So what it'll do is continue to search through that array using the for loop until it finds its value. Now, the way I trace through the code is up here on top. I've got several arrows and different symbols. The step into is all you need to worry about for now. These other ones you can learn at a later date, and there's plenty of information on those particular functions. Most all of the debugging facilities and just about every IDE and every programming language works pretty much the same. You can step into the line of code, you can step over it, you can step into a function, out of a function, you can just continue running the program, and that's what these icons will do for you. So I'm going to step into this line, okay? It's executed that line, and what I should see is the result of that execution. In PyScripter, the console is down here at the bottom of the display. So there is the result of my print statement right there, okay? I'll step in the next line, which is also a print statement, and it's going to give you some more information though. It's going to tell me inside the array of indexed 99 plus the counter is 4, okay? So that's where I stand right now in the program. If there was a failure in my logic, okay, this is where I'd start to see those logic issues coming up. If I continue to step through the code line by line, I still stay in the for loop. Nope, I don't stay in the for loop. Apparently it's found what I'm looking for, so it's done. Now, what I probably should have done is position this a little differently, because what's happened here, if you think about it, once this search value is the same as the subscript, 9999, that's what it printed this message out, and that's what it did. It just hit that part of the executed lines of my code. So that wasn't terribly interesting. Let me change the breakpoint to something out here on the for loop, a better place to see more what's going on with the program. Let me start it again. This time it starts with the for loop. The subscript, or the first position of the array, is 0, so it should be a value of 12, okay? And let me walk through this one. It's going to say basically, is the value of 12 equal to 99? It isn't, so it's going to bypass that, increment the for loop. Now it's going to come in, and it's going to take the next value, which is 22. Is that the same as 99? No, it's not, so it's going to continue to walk through that. Walk through that value, walk through that value, walk through that value, and lo and behold, I now have a search value of 99. I have a subscript of 99, which is that fourth element, and that's what it shows me in this next statement is what element it found it at. What I had done in my first debug session is I'd placed the actual breakpoint inside the if statement, which was only showing me that it found what I was looking for, only, really walk through 2 lines of code, a bad position to really get a good picture of what was happening with this program. By putting it on the for statement, that gave me a much better idea of how the program was working. It seems to be working okay. Now, if it wasn't working okay, what I would find is perhaps the incorrect function would be called. Or perhaps the input parameter wasn't getting to the function correctly. But that would help me isolate where the logic error was. Of course, it's still up to me to fix it, but again, it's giving me some feedback that's going to help me figure out how this actually needs to get fixed. Now, the other nice thing about a debugger is as we get into class objects, there seems to be a lot more jumping around in the code. I mean, I think you probably already saw that with functions. You're going to see more of that when we get to the chapters on object-oriented programming. So again, the debugger is handy for finding errors, but also kind of handy if you just wanted to kind of walk through the code with you. And so you understand what should happen next, and you can validate it with the variables and holding the cursor over the top of them. These other screens, for example, variables is the one I like. It'll show all your globals. It'll show you all your locals. Of course, the locals are going to change as you go. Globals might be a better one to look at to determine what's happening while this whole session is running. But there's other options here too you can look at. So that's kind of a starting point. PyScripter does everything Thony does, except it's got a much better debugger. I would argue there's some other tools built in here too that make you more productive as a programmer. So I would give it a try. I'm going to also try to do something with Visual Studio Code. It's also another IDE which seems to be very helpful when developing Python scripts. If you have any questions, please let me know. Thank you.